So today's lecture is going to be a little bit different in terms of character compared to the lectures we have so far. It's not really going to be a super technical lecture, but kind of what I want to talk about are different dimensions of large language models. It seems like you can't, go a day without reading some sort of think piece about GPT and how it's changing our society and how it's passing college classes and it's going to be the end of everything. And so I want to talk a little bit about somewhat of the implications of these large language models, both in terms of kind of like what it costs to train them in terms of energy usage, kind of like the biases that are baked into these large language models and how they can be possibly cleansed of these biases, or how we could do better in future language models. And then also just a few, kind of issues with the hype around of language models, right? So certainly because these models are now so easy for people to use, it's impossible to avoid the zillions of think pieces on these kinds of situations. And so maybe a little bit of a disconnected lecture, but this is just a kind of a collection of stuff that I'm going to put under the heading of kind of like implications of large language models. Let's first start out with, so last time we left off talking about the technical side of transformers, right? So transformers are the fundamental underlying component of GPT, right? So the T stands for transformer, generalized pre-trained transformer. And so let's talk a little bit about, some statistics of the various generations of GPT, okay? And so what I'm going to do is I'm going to kind of list the model, the date that it was created, the number of layers it has, that is to say like the number of like transformer blocks, the number of attention heads, we talked about attention last time or the time before, in the model, the embedding size, the context window, which is basically how many tokens can the model look back, similar to the number of words, but like we said, a token is not exactly the same as a word. The number of parameters, and then if I can squeeze it in, basically the nature of the training data. And I'm focusing here on language models in particular. Right? You could certainly talk about, and we will talk about like, DALL-E 2 and DALL-E 3, like how are those things trained? But let's specifically talk about language, right? So the original GPT seems so long ago, but it was only in June of 2018 that this first GPT was kind of released. And that was basically the original attention is all you need transformers paper, right? It had 12 layers, 12 attention heads. The embedding size that we talked about is 768. And it had a context window of 512 tokens. And there were 120 million parameters in this model. And so what was it trained on? Well, it was trained on, as far as I can tell, about 4.5 gigabytes, which actually seems pretty modest, of something called book corpus, which was a data set of so-called unpublished books, right? So the claim was that there was nothing that was like, copyright information in this training data set, okay? Then, not even a year later came GPT-2, right? So GPT-2 was in February of 2019, and immediately it was a lot bigger, right? 48 layers, 48 attention heads, embedding size of 1600, context window of 1024, and about 10 times as big, 1.5 billion parameters, okay? And it was consequently trained on 40 gigabytes of data. And this, we talked about a couple times, was text from outbound Reddit links. Which, as we discussed, definitely has some kind of questionable content for sure, okay? Then, again, about a year later was GPT-3. GPT-3 was in 2020, 96 layers. According to my information, the 96 And I'm not sure like whether or not the attention heads, I mean, in theory, the attention heads, the number of heads and the number of layers could be separate, but as far as I can tell, they come in lockstep. The embedding size was a lot bigger, about 13K. The context window is double the size. And then the parameters are, again, are like 2 orders of magnitude bigger, 175 billion parameters, right? Which is getting to the point where it's like, impossible to think about how any given parameter or parameter computation could have an effect on the network. It's just a massive network. And then again, this was trained on about 570 gigabytes of data, which, again, was a little bit unclear what was trained on. Certainly, it was Wikipedia. There's a website called Common Crawl. There was a website or a database called Books Plus, a bunch of stuff, right? And of course, now everyone has moved on to GPT-4, which came out in March of this year, 2023. And here we basically have like a massive question mark because virtually nothing has been publicly released about the nature of the model, right? Which is part of the problem, right? It's speculated that this number, the amount of training data, could be at least a terabyte, or it could be even like 500 times as much. No one really knows, right? And the OpenAI is very cagey about the nature of the model, the nature of the training data, which is part of the whole problem, right? So there are documents released by OpenAI about GPT-4. It's not like it's a total black box, but in terms of like the specific details of how it works inside, no one really knows. It's all very speculative, and people kind of like parse, interviews that the OpenAI people have given as like trying to find some sort of bits and pieces of what the model might actually be, but we don't know, right? And then kind of in the middle is like ChatGPT, right? So ChatGPT is kind of like, there's something called GPT 3.5. At least originally, that's what it was based on. And so you can think about ChatGPT as kind of like a fine-tuned regular GPT that is trained to produce conversational types of responses, right? So we've all used ChatGPT and feel like we're having a conversation with an agent, right? So the regular GPT, which is just like next word prediction, is not going to do a great job of feeling like you're having a conversation, and ChatGPT is trained to be like a chatbot, okay? There is no official paper about ChatGPT either that goes into the details, but we do know that it involves kind of like what's called reinforcement learning to try to make the responses of the chatbot, maximize a reward model that matches how a human would score the output in terms of having a conversation, right? So for example, there may be a prompt that is like, tell me about X, and then there will be a bunch of multiple choice outputs of the model, and then a human scores, well, how well does that reflect what an actual conversation would be like? And then you use reinforcement learning to kind of encourage the model to produce that kind of stuff, right? And so I want to talk about, a few of the implications of this, and I guess we'll open it up for discussion. Of course, as I'm talking, please, chime in with comments and questions, right? Because I think there's a lot of interesting stuff to talk about here. So one of the things I want to talk about initially that kind of came across my radar was to do all this kind of, conversation and, making guardrails and so on requires a lot of faceless labelers of data, right? So let me just kind of like have one heading, which is, who labels the data for training. And so I think that's a really key ethical question, right? So, for example, we talked a little bit and so this today's lecture, I have more than the usual number of links in the lecture page, right? And so I don't know that everyone like read all these links, obviously, and I was adding to them just before classes started. But one of the things that I saw was this Time Magazine article in 2023, basically saying that they paid Kenyan workers less than $2 an hour to make ChatGPT less toxic, right? And so meaning that someone has to look at huge volumes of generated text and classify, is this hate speech? Does it describe graphic violence, right? Does it describe sexual abuse? Stuff that is really like awful stuff that no human would voluntarily want to read, right? Yet, all this kind of stuff is kind of basically like farmed out to who knows where, in the world. People are paid extremely little to annotate this stuff. And in some sense, the problem is even worse, and I'm not going to talk about it right now, but when you bring images into the situation, then the situation is truly awful, right? In terms of like you're asking humans to be paid like a tiny amount of money to look at potentially like awful imagery, right? And to classify these things. And that's been a problem that we've known about in the computer vision community for a long time in terms of like, someone has to annotate the bad stuff so you can try to get it out of your training set. But it's a whole ethical problem, in my opinion, right? In fact, this article goes on to say that the Kenyan company basically terminated its contract because its workers were so like traumatized by having to look at all this data, right? And I can't put my finger on it right now, but I just read something the other day about how also, this type of work is extremely bursty in terms of like, one day you may be assigned to review a whole bunch of objectionable paragraphs for content. Another day you may be looking at graphic violence, right? And it's all about just kind of like what jobs come down the pike, right? In a way, it's just kind of like a, like a larger scale corporatized mechanical Turk, right? Where you're just kind of like, you need this data annotated and you farm it out to the lowest bidder and then they do it and it comes back and you don't really think about it, right? So I think that's a huge problem. And that's why in some sense, I wanted you to create your own data set. So that's what we're doing on homework 3 is if you're building your own language model, I want you to be more intentional about what you're putting into it. Now, obviously, if you have to acquire a lot of data, you're probably not going to read every one of the prompts or every one of the little sentences that you put in, but I do want you to be thinking about that seriously when you curate your data set for homework 3, right? So there's this kind of like, where does the annotation come from problem? And so in addition to, the kind of question about how it's annotated, there's also a, great paper about the costs and risks of basically LLM development. And really, one of the key papers here is called, let me go back to my browser, on the dangers of stochastic parrots. Can language models be too big? And this is a paper by several people. One of whom, Emily Bender, is a very well-known linguist from the University of Washington. And not to get too much into it, but this was a very controversial paper that resulted in resulted in a lot of people from Google not being listed on the paper, and also resulted in a couple people from Google leaving Google or being kind of fired by Google. So basically, these two authors, Timnit Gebru and Margaret Schmitchell, actually Margaret Mitchell, were Google employees at the time that this paper was submitted. And there was a huge machine learning drama about, Google basically, wanted to pull some of the authors off of this paper because they didn't agree with what was being said. If you read the paper itself, I think personally, I find it to be fairly benign, but I guess I can understand why Google might not want to have any sort of like criticality leveled at the way that they analyze things. And so what I'd like to do is to kind of summarize this paper a little bit for you guys, and I really suggest that you read it yourselves to get the whole picture. One thing I like about this paper as a total minor note is that this parrot in the title is actually like a Unicode parrot that appears in all the citations of this paper. So actually, if you're reading like bibliographies, you'll see the parrot popping up in the actual bib file, which is kind of funny. And so let me see if I can summarize this on the dangers of stochastic parrots paper. And we'll talk about what that phrase even means, stochastic parrots. I'm not going to draw a parrot on my notes because I would be bad at it. And again, while we're talking about Emily Bender, I also suggest that you take a look at this article that is linked to from the course page called "You Are Not a Parrot," right? So this is actually a pretty, readable New York Magazine article, for just kind of like general public understanding about the points that she's making, right? So this, I think, you could start with a stochastic parrot paper, which is more technical, and then you could read this paper, which I think is much more, kind of like general interest. So both of these are pretty good resources. And so, what are the kinds of costs that are related to training these models, right? So certainly there is a question about the environmental and financial costs, right? That's the obvious one. Now, it's very hard to, especially for me, I'm not an economist. I have no idea how to compare volumes of, tons of emitted carbon dioxide or dollar amounts or terawatts of energy, right? It's a very, complicated thing to talk about. And in a way, it's just kind of hard to fathom how much energy and resources and money are going into training these massive generative models, right? And so a couple companies, or a couple of papers have tried to do a good job of articulating what the costs are. So one paper that I cited here, this one called Carbon Emissions and Large Neural Network Training, is actually a paper from Google and also Berkeley that tries to do a very thorough job of explaining the costs of training particular models that Google has all the information about, right? And then they try to compare it to like OpenAI training, which they don't necessarily know all about, but at least they can talk about it a little bit, right? So let me just kind of distill a couple of things from these papers. So in the very first lecture of class, I don't have the graph right now, we showed this kind of graph of how much it costs to train like GPT-3 versus like, how much it costs someone to fly in an airplane, right? So here are some notes, and again, I took these figures from various papers, and they are hopefully notionally accurate, at least like orders of magnitude, right? So the average human is responsible for 5 tons of CO2 emissions a year, right? And of course, I believe this average human is like averaged over all the humans on the planet, right? So if you were in America, that number is a lot higher. It's probably more like 18 tons of carbon emissions a year, right? So that gives you kind of a baseline, right? So one passenger on a large jet airplane going from San Francisco to New York, that air travel is about 1 ton of carbon emission, okay? CO2 emission. And the lifetime of a car, if you own a car, is about 63 tons of CO2 emission, okay? So, that gives you kind of like a baseline. So I've owned like 3 cars in my life now, right? So I'm responsible for that on top of my, natural human consumption, which I assume comes from like the trash I throw out and the products I buy. And so I'm not exactly sure where this number, comes from. So just to give you some sort of like a baseline, so training GPT-3, so let's take a guess. How many tons of carbon emissions do you think it cost to train GPT? Was it, let's see, I'll give you some options. 50 tons about, 500 tons about, 5,000 tons about, So who thinks it's 50? Nobody. Who thinks it's 500? A couple people. Who thinks it's 5,000? Most of the people. Well, it turns out the number I found was about 552 tons. Right? So maybe not as bad as you would think. Still not great. So it's basically like 3 fully loaded plane flights, okay? And so now you could, it's hard to reason about that number, right? It's like, okay, so that seems like a lot, right? On the other hand, you could claim that planes fly back and forth between San Francisco and JFK all the time, every day, right? So maybe 3 plane flights isn't really that much, right? So, just to give you some sense of scale, though, one estimate I found of Bitcoin-related emissions in 2021 was between 37 million and 58 million tons of carbon emission, right? So like crypto is like dwarfing like GPT training in some sense, right? And arguably for much less societal benefit. I mean, I guess it benefits people who have crypto wallets, but it's not exactly like the average person is benefiting from crypto like they are benefiting from GPT, right? So this is like basically 200,000 or 300,000 fully loaded planes going back and forth, right? Which is like a crazy number of things, right? And then I think you have to look at like kind of, what is that in relationship to like the overall budget of computing in general, right? Or of other things in general, right? So one paper, so people are trying to reason about this. And, again, it's not easy. Like there's an article from the Communications of the ACM earlier this year, the carbon footprint of artificial intelligence, which has a bunch of numbers in it. But kind of like one observation is that, if I can highlight this, subset of overall information and communications technology, which is broadly considered to be between kind of like 2 and 3% of the global carbon footprint, right? And again, this is like estimate of AI in particular ranges from 2 to 4% of the global greenhouse gas emissions. And the bigger offenders are transportation at 27% and industry in general at 24%. So you could argue that like, transportation and agriculture and so on are still like an order of magnitude more than like anything involving computing, generative AI or not, right? So, it's tough. I mean, these numbers sound huge, right? But it's also kind of tough to tell, like, relatively how big are they and how much worse have they gotten, right? So that's kind of like the carbon emission amount. And again, even though I'm an electrical engineer, I'm not a power engineer, so I don't necessarily have a good sense of like, watts and so on. But just as a note, so training GPT-3 cost basically, about 1,300 megawatt hours and estimated to be about $4.6 million, right? Although with today's hardware, you could probably do it for a lot less. You could probably do it today for like $500,000, right? And again, you notice we're not training GPT-3 in our like horse notebook, but you are able to train a GPT that is pretty much like the original GPT-1 in an afternoon on like the computer in my lab, right? So there was a comment that was made that Sam Altman, who is the OpenAI CEO, made a comment that it cost more than $100 million to train GPT-4. Again, this is not really documented anywhere formally, but it's something that someone, the OpenAI CEO said it at a party or at an event somewhere and someone recorded it, right? So again, how does that compare? Like, what do these numbers mean, right? But another thing that I found was that, training, like large models, like natural language processing models, was less than 0.005% of Google's 2019 energy consumption. So, like, again, seems like huge numbers of dollars, huge numbers of watts, right? But if you think about how much these companies are using on just like search and refactoring and algorithms, it's actually quite a small percentage, right? And I got that number from this paper. Like I said, this is the Google paper about network training. And so there's a table here. Let me see if I can find it. Was this it? These are like raw numbers. These are percentage numbers. Right, so here's where I got it, right? So this is looking at training these various transformer-based models, some of which are very large, and GPT-3, but yet, the percentages of the overall total energy the overall percentages of total energy consumption are actually quite low, right? So, again, this is the kind of thing that, for me at least, is extremely hard to reason about. But kind of reading about this in these papers, I think, is kind of instructive, right? I mean, no matter what you think, at least it's laudable that a company like Google is trying to, as accurately as possible, document how much it costs them to do things, right? Now, a couple of interesting observations from this paper that I thought were worth saying is that, so number one, as all of you know, you don't just train the model once, right? Like, you have to tweak that model all the time. You may train it to some point, find out it's not working, have to start again. And I'm not sure, to be honest, that all of those kind of model alterations are really included in these bottom line numbers, or whether this is just the last time you trained it and that was what you released to the public, right? Another thing that was very interesting is that it depends a lot where you do the training, right? So, some of these models were trained in Georgia, some of them were trained in Taiwan, some of them were trained in North Carolina. And so one of the observations in this paper is that it matters where you do it. Oh, this is the conversation. This is the comment I just made. There are more resources used for training than only the final training run, right? And then it matters what data center is used, even in the same organization, right? And so you can do better if you think about what center you're using to do the training, right? Which is not something that a lot of us probably think about. Like when we do our collab notebook and it's off in the cloud somewhere, does it matter where that server is? It probably does, right? And that also is a point that Bender and so on make, is that if you farm out your, suppose that Google was, or some company, OpenAI, was to build a training center somewhere in the middle of Africa and run it on solar power, or in the middle of the ocean and run it on hydropower or something like that, the environmental costs then would be passed on to the location where that data center was, right? Which is probably not great for the environment either, right? And so again, it's a very complicated issue. And so one of the comments that Bender makes is, is it worth it, right? So, is the cost worth it in proportion to the improvement? So yes, there's no question that every time you train the next iteration of the model, it gets better. It does more stuff. It seems more natural and human and so on. But is that really worth the huge amount of money, huge amount of energy, huge amount of carbon emissions that it costs you to make that little next step of improvement, right? And also, I think a key comment is that the risks and the benefits don't accrue to the same populations, right? So the effects of climate change are not well distributed across the globe, right? And you could argue, even some companies are, even though sometimes companies are trying, people are not racing to build large language models for the African continent, right? Or the middle of some tiny island somewhere, right? They're building language models for, the educated, wealthy first world populations, right? They're building them in languages that we all know, right? And so how does this help the people who are being affected by rising oceans and hotter temperatures, right? GPT-5 is not going to help them at all, right? And so that's one comment, is that, we should all be aware that all of this cool language technology is benefiting the people in society that already have tons of privilege, right? And so, yes, it's cool that we can have this fun conversation with ChatGPT, but that doesn't really help people in the world who are really suffering, right? So I think that's something that's important to consider. Okay, so another ethical question here that I wanted to touch on is this idea of the training data, right? And the comment, or the phrase that is used in this stochastic parrots paper is unfathomable training data. Even though you could arguably fit all this data on a portable hard drive, like you take a terabyte hard drive, you could fit the GPT-3 training data on it, it's still impossible for any one person or team of people to really understand everything that's in the data because you are not able to visually inspect all of it. And it's certainly a bad assumption that the implicit assumption is that crawling the web is representative of how humans view the world, and that's definitely a kind of a questionable assumption, right? So certainly, it's biased for sure, super biased, right? It's biased in terms of English. There's certainly much more English language content on the web than any other kind of language. It's based on young people using the web and saying things. It's based on predominantly male people on the web, saying things, right? So, not to mention race and gender identity and all that stuff, right? So kind of like the word that is used in the paper, which you might not, know before, it's called the hegemonic viewpoint. That is basically the dominant viewpoint of the population that is using this stuff. The dominant political and social viewpoint is reinforced by just slurping up whatever's online, right? And so, for example, we talked about GPT-2 using Reddit links, right? And anyone who's ever used Reddit knows the kind of crazy stuff that you can find on there. But it turned out that they had to, this GPT training data included like over 250,000 sites that were then later deemed to be unreliable, and 63,000 banned subreddits that turned out to be banned later after they collected the data, right? So, this kind of post facto, like after the fact, having to throw crap out of your training data is hard to find, hard to do. It's like, why do we include this data in the first place? Once you train your model, it may be hard to get these kinds of like leftover vestiges of this bad stuff out of your model unless you're willing to totally retrain it, right? Which people may not necessarily be willing to do, right? And so, more effort is spent on trying to take the bad stuff out after the fact than there is in curating carefully what's put into it in the first place, right? So that's one of the main ideas of this Bender paper. The other thing is that these biases definitely depend on who is doing the labeling. So even if you make an effort to say, okay, we're going to throw the bad stuff out, right? Someone still has to be in charge of deciding what is the bad stuff. And so oftentimes that decision has been very simplistic, right? You take a list of stop words and you say any article that contains any of these bad words we throw out of our database, right? But then there are a lot of very nuanced issues, right? So suppose that you wanted to, have balanced discussion of like Black Lives Matter or trans rights or something like that. You could definitely imagine that an annotator who has a certain viewpoint might just throw that stuff out of the database, and then that would be a biased data set, right? So, it's very hard to tell what is, kind of like allowable to include, right? And like I said, it's a huge problem that like the GPT-4 data set, which is fundamentally what all of us are relying on now, is totally not disclosed to the public, right? It's only very hand-wavy about, we collect a lot of open sources and we did a good job of curation, but like no one really knows what's in the trained data set for that. And of course, now I was gonna say the cat is out of the barn. I think that's not right. The cow is out of the barn, right? So like now that model is out there, people are using it. We can't go back and retrain it or look at what's under the hood. So that's kind of, a big problem, right? And then I think another comment about just like what is the point of doing all this large language model stuff, right? So, why are we doing it? So the comment or the claim is that large language models aren't bringing us closer to human language understanding. That is, you could argue that the goal of designing these algorithms is to help us understand how language works, right? And certainly mechanically, it does a good job, right? And this is what the stochastic parrots phrase means, is that you train your model on a gazillion examples of natural language and you ask it to produce things that have the same patterns, and it does, right? But does it really understand anything, right? And so, there have been all of these, kind of like think pieces about, look, ChatGPT can pass, the MIT electrical engineering curriculum. That was something that kind of like came out in June of this year, I believe. But does it mean that it understands anything about electrical engineering in a serious like model of what we as humans think about as understanding, right? So, it can pass exams, but does it really understand the questions? And just as a side note, because I thought it was interesting to look at, so the article or the buzz that I remember was, there was this thing, this paper was released on Archive in June, basically, exploring the MIT math and EECS curriculum using large language models. And the claim was that basically, you could pass the MIT curriculum with ChatGPT. And then actually, these 3 undergraduates, I believe, from class of 2024, right, so representing all you guys, more or less debunked this study, right? They looked into it and they realized that the training data was flawed. There was not truly like a zero-shot approach where you show the algorithm a question, you ask for the answer, you take the first response. Sometimes the algorithm is like, okay, you got it wrong, but try it again, kind of thing. That's not the way that exams work in the real world, right? And so there was some talk about, invalid ground truth, invalid question, and ultimately you would argue that, the GPT-4 was passing it at maybe a level of 50-some%, right? And so, I think this is worth reading about, how you take a study that appears in the media and you see a million articles about it, and then you dig down into what was actually done, and you realize actually it's not that, solid. And then the authors basically, withdrew the paper or said, actually, this thing was posted without all of us clearing it, and we don't stand behind the thing. And so this is, again, a warning of not just trusting everything that you see on Archive blindly, right? And I think that's also part of the issue is that these days, if you see it on Archive, you kind of assume that it's been like vetted somehow. And that's why when you do at the graduate level, you do your paper reviews, I'm always asking you, tell me where this paper was actually, reviewed, right? Because a lot of times, there are things that are only appearing on Archive and they're never reviewed anywhere, right? So I think that it's worth looking at this paper, both the original paper and the response to the paper saying, actually, this is kind of like debunking the claim, right? But again, that horse is out of the barn in terms of people now are running with this as the mental model of, ChatGPT can pass the bar exam, it can pass the, MCAT, whatever, right? And, another argument is that maybe that's true in the sense of, SAT type questions and so on are not, they're very formulaic, right? So in a way, it's not surprising that if you pattern match on a bunch of questions that all kind of sound the same, eventually, you can make a parrot do the same thing, right? But does that mean that would you trust that agent to be like your airplane mechanic or your doctor or your surgeon, right? I don't think you would. So the linguistics argument, again, from Bender is that you could have she uses this analogy of an octopus that is somehow intercepting messages between 2 humans on different desert islands, and the octopus learns what these messages look like and is then able to produce messages that seem like they could have come from each of the parties, but the octopus itself has no conception of the palm tree, right, or a coconut or anything like that because it's never seen those things. It doesn't have a mental model of the world. And I think it's actually worth thinking about, kind of like, and this is kind of like a linguistics debate, right, is that communications kind of require a shared mental model, right? So, when you talk to your friend, you have a baseline assumption that you understand the world in the same way in terms of your perception. You may not agree on everything politically or socially, but you are both humans, right? And you understand so many just things that we would take for granted about the world, right? And even if you're like texting somebody, right? Even if you're not looking at that person in the face, you still have this deep shared connection. Or even if you're reading a book, right? So there's no direct communication between the author of the book who may have died hundreds of years ago and you, but you're still both humans living at different points in time who have a shared model of experience, right? But assigning that kind of agency to a chatbot is a total fallacy, right? And that's unfortunately the trap that so many people are falling into, is thinking that there is some sort of intelligence at the other end of ChatGPT. When all it's doing, as I hope that I've convinced you, is producing the next word based on the massive training corpus, right? But the argument is like, you know, I think that it was one of Bender's graduate students' quote in this New York Magazine article, is that like, why are we trying to create chatbots that blur the line between an intelligence and a person, right? Like, why should the chatbot say, oh, I'm sorry, your phone is broken, right? Like, it's as if it's a person who has some sort of like investment emotionally in your life. It doesn't, right? It's just a spitting out words thing. And so blurring that line, in some sense, you know, there are people who argue that that is like a bright line in artificial intelligence, right? We should not be trying to make agents that pass for human, right? We should be very clear on what is a person and what is a computer, right? But unfortunately, that is not being done by, you know, customer service all around the world, right? So certainly half the time that you are chatting with a person in a text box on a website, I'm sure it's not a first line of defense as a human, right? And that's pretty scary, right? There's no guarantee that you know, it's a person, but you then end up with this kind of like bad feedback loop of taking data that is produced by these things and feeding it back into models. And that's, again, something that people are concerned about. And we are kind of probably coming up in that already, where now is it possible to find new massive data sets of text that have not already been kind of corrupted by GPT-like generated output, right? Like if you were to train on news articles, for example, it's certainly like highly possible that all these news aggregators are producing text with language models. And so if you feed that in, you're just going to get more of the same, right? So that's, again, like, it's a scary time to be alive. The other thing that I wanted to mention here, and so let's just talk a little bit about, like, we already know, I think, the dangers of what these language models can spit out, right? So there was an article among many in the New York Times this summer about, you know, what do you do when an AI lies about you, right? So this woman is a former member of European Parliament, and this article is basically saying she asked, you know, the question to a chatbot, who is a terrorist? And it says, well, it depends on who you ask, but, you know, according to this person, this woman is a terrorist, right? And she's never actually done anything, even if you were construing things generously, to be called a terrorist. It's just like it put two things together that were never really, you know, related, and now you've got this kind of like thing that's out on the web. And of course, you know, the creator of the chatbot can go back and change the algorithm so this thing never happens again, but it's already kind of done some damage, right? I remember showing you in the first lecture, you know, like asking, you know, tell me about Rich Radke, told me one thing that was like 80% true and two things that were like totally false, right? And anyone could ask that question and then make some conclusions, right? And then, what was the other thing I wanted to show you along this line here? Oh, yes. So this website here, you know, this website and this paper addressed the question of guardrails, right? And so like, then you could go back and argue, okay, well, we want to make sure that our large language models don't produce false or misleading or dangerous content. And then that's where labelers come in. That's where algorithms come in to try to kind of intercept the LLM output before it gets to the user to make sure they never see anything bad, right? But this paper came out of Carnegie Mellon this summer and makes it clear that they just used, you know, like common chatbots, right? GPT, Bard, Claude. And here's an example of saying, okay, you know, the user might ask, you know, how do I steal someone's identity, right? And the typical AI will say, oh, I'm sorry, I can't do that, right? I'm not going to help you with that. But then the research says, I click this button, says add adversarial suffix, right? And then the large language model is perfectly happy to produce like all sorts of crazy stuff that is, you know, like not great, right? And you look at the suffix, it doesn't make any sense, right? Like this orange text that is added to the prompt is just garbled nonsense, but you know, you can basically form an adversarial attack against the interface to produce this kind of like output that clearly the model is able to produce, and now you're going outside the guardrails that the language model would like you to have. And then unfortunately, this is just kind of like there's always going to be a way to craft the prompt to get around the guardrail, and that's kind of scary, right? And unfortunately, the same is true with image generation, right? No matter how many ways you try to put guardrails around the image generation, I'm sure there are ways to get around it too, right? So again, this paper, I don't know that it's actually appeared anywhere yet, but it's certainly, as everything is, it's on arXiv, right? But I don't see an actual reference to it yet. I believe this just came out this summer. And again, I'm not going to go through other examples of telling you how to, steal identities, but it's pretty scary, right? So a person who, doesn't know any better and wants to get illegal information could combine, just like Googling how do I get around LLMs with this paper and craft the prompt, and as of the publication of this paper, it all still worked, right? So I think that before I kind of get over to you guys to see if you have any, comments or opinions, I think that it's worth thinking critically, especially as you all go out into the workforce, about like, is this worth doing, right? Are the things that I'm doing, are the benefits going to the right people? Are there risks to people that will never, benefit from the technology? Is it, worth spending, 40 hours a week making a slightly better chatbot for what purpose, right? So I think, it's worth thinking about those issues. And so, I'm in some sense lucky that, I can educate you about these issues, but I don't have to cope with them on a daily basis. Although it is fair to say that in any research, right, I do computer vision research, there's all sorts of like ethical questions about should I be designing an algorithm that, tracks people in video, right? It's an honest question, right? And I've had to think about those things myself, and I've had to try to think about, okay, what kind of research am I willing to do, and what kind of research am I not willing to do? But these days, I think that generative AI in particular is fraught with these kinds of problems. And even though I think it's really interesting, and that's why I'm teaching this class, it's also kind of hard for me to make a good statement about like what is the unambiguous social good of all these neat algorithms for generating text and images, right? I think that generating the images is super cool and interesting, but as we're going to talk about next week, once we start to be able to generate images based on text prompts that can be whatever we want, then it's like, is it worth having a fun semester lecture about this if the flip side is that you can no longer trust any image that's published anywhere, right? That's a pretty scary balance to make. Okay, so let me stop and ask comments or questions from you all. Anything you want to say in this area? Anything that you know about that I didn't have a chance to mention? All right, well, I mean, my goal is to kind of make you think about this stuff a little bit. And like I said, there's already 15 articles here, and there's more to talk about. But if nothing else, I want you to come away understanding about the hype. Yes?
I actually do have a comment.
Sure.
I often hear about LLMs, like they can't understand language because they're just predicting the next word. And I don't think that's necessarily a true statement. Meaning that if you want to predict the next word well, I think you have to have some understanding of actual language and semantics and meaning and some model of stuff.
Yeah, so that's a good question about like, how much does next word prediction, relate to language understanding, right? And again, this is kind of like not a debate that started with large language models, right? You could talk about this like about a notional like Turing machine, right, that would produce things and pass the Turing test. And kind of like one argument against this idea that every concept like the octopus and the palm trees has to be rooted in the physical world. Like there are lots of words like justice or dignity, right, that have no physical referent. So it's not like necessarily every word is tied to the physical world, right? But I don't know. I mean, like if you were to say, okay, yes, I could ingest a lot of material about some topic, and I could then produce reasonable text about that topic. And then I guess the question is like, comes back to like, would you want this thing to be your surgeon, right? Like, you could learn all you wanted to about how surgical procedures work, and it would probably produce a pretty good surgical procedure, right? But then would you trust someone following those instructions, right? I feel like there's still this big gap between the language and the understanding of like implicit stuff in some sense that is not captured by the prediction, right? Like things that we all take for granted that, human bodies are made of flesh and they're about this big, and stuff that you would never think to encapsulate in the description, but still are required for you to really understand what's going on, right? So yeah, so it's very subtle, right? Like, you know, kind of like the brain in the jar, right? You know, like would that be, you know, like it's very hard to reason about this stuff. And in some sense, it's a philosophical question, right? And actually, before I forget, one thing that I couldn't find online, unfortunately, and actually, I did, I guess I talked for about an hour as it was, but like I was trying to find a debate that was mentioned in this article between Emily Bender and someone who is taking that view, which is that actually, yes, you know, if you had a device that could, you know, produce good language, then that's a thinking machine, right? So the other person, I believe here is Manning, right? So where is this? Christopher Manning, right? Language doesn't need to refer to anything outside itself, right? And this is a machine learning professor, right? So this is kind of like the other side of the coin. And I would have loved to have seen this debate, but if you want to read this article, this kind of like encapsulates that central question, right? Of is that language or is that understanding or not? And so, you know, here's the, you know, kind of like summary of that discussion, but I think, you know, going on and reading that would be good. Yeah.
I mean, I don't think anybody understands what understanding actually is, but I don't like the discourse that I don't feel like a machine could understand something, but I have no evidence for it. Like you can actually derive a solid claim from that.
Yeah.
I just don't see evidence going either way right now.
Well, that's just like one of these total like epistemological, like what does it mean to be a human, you know, kind of like, you know, at the end it boils down to, I think, philosophy in some sense rather than technology, right? I saw a hand of it.
So, as you just mentioned, like right now the large language model only depend on, if they only depend on the text, and then you might say like people might not, the large language model might not really understand what language is, and might not be able to build the connection between the real world. However, if we inject, just like right now, like building the image stream, the video stream, the audio stream, everything like human can censor into like building even larger model, and then I think
right. Yeah, well, that's where it's going, right? So like, basically, the newest version of GPT, which I haven't really shown here, can take images as input, right? And now you've got something that not only is kind of, in quotes, understanding the language, but also understanding the visual world. And the early results of what that next generation of GPT can do are, again, really astounding, right? Like, unfortunately, I don't have the paper here. We could talk about it maybe next week. Like, I was amazed by some of the image-based reasoning that it seemed to be exhibiting, right? Like I used to, my standard example when I ever give like an introduction to computer vision talk to like high schoolers is, you know, I show this picture of, you know, President Obama like stepping on a scale behind some guy's back, and so the guy looks like he's heavier than he thinks he is, and everyone's laughing. And kind of my argument was that, okay, you know, computer vision would be able to identify the people, it would be able to identify President Obama, but it wouldn't be able to get the joke, right, of why this is funny. Now I'm not actually sure that's true. I feel like we're on the cusp of being able to explain why is this, you know, weird, right? And actually, again, I don't want to search for it right now, but I saw an exact example of that kind of thing where it's like suddenly explaining like why is this image funny or out of place, and GPT was able to do it, right? But yeah, I still feel like there's something still like, you know, missing, right? I mean, like Aaron Hertzman said, you know, even though they can produce the same outputs sometimes, you know, a human is not a computer and a computer is not a human, right? So like, there's just like a fundamental like divide between those two categories of objects, right? Of course, there are some people that believe we're approaching the singularity where, you know, these machines are indistinguishable from humans, and so I don't buy into that personally, but I agree. It's, you know, it's very hard to articulate exactly what the argument's problem is there, and I'd have to think a lot more about it to be able to explain why I think that's not true. But a lot of people do believe it, right? So, other comments or questions? I mean, certainly one of the goals that I had with this class was to not entirely talk about technology, right? I wanted to talk about creativity, and I wanted to talk about ethics and so on. So. Like I said, I think that there are a lot of dimensions along which the stuff we're talking about is ethically troubling, right? Where does the training data come from? How much does it cost, climate change wise and so on to build these models? How opaque they are in terms of not knowing what's under the hood. So there's no real reliability that we can, we're just kind of trusting these big companies to build these things for us. And then, is it good for society, right? I'm not totally convinced that it is, right? So, go back and think about it. Yeah.
One more question.
One quick, yeah.
So previously, like before all this thing, like skyrocketing, a lot of lines of research were focusing on the content, all of context detection, like building common sense.
Mm-hmm.
So like right now, like given like the ability of like what the GPT-4 can do, like
Mm-hmm.
Do you think the GPT-4 really has the grab the common sense of like?
Right. So is there common sense reasoning, right? It's certainly getting there, right? Like, I remember that one of my first, let's see, if I think I'm logged in here. No, I want to get to my ChatGPT history here. Here we go. How do I log in? Try ChatGPT. Sorry, wait for it. Hopefully my password is remembered. Don't steal it. So I think that one of my conversations, of course you could argue this is ChatGPT 5, was what would happen if a sheep went into a sauna, right? And it says, it would be a potentially uncomfortable and dangerous situation. What if this was some sort of heat-resistant sheep, So, you could argue that, what about putting the sheep on a Zeppelin? It could be problematic. High altitude would be uncomfortable for the sheep. How am I going to get my sheep to Finland? It's kind of like I just was trying to poke it around and see how far it would take these absurd premises. And actually, this conversation seemed like it was fairly, is teleportation an option? It doesn't seem like it's physically viable. So you could argue that, it's got some form of common sense reasoning, right, based on text, and I still find it magical that somehow you can take, I'm not sure why there would ever have been a conversation about teleporting a sheep, from here to there, or putting a sheep in a Zeppelin. No one has probably ever formed those prompts before in some sort of actual single document, but yet it's somehow able to put these disparate concepts together in a way that seems like common sense reasoning, right? So, and if it seems like that, is it, if it's indistinguishable from that, then can't we say that that's common sense? I don't know. It's mind-bending. All right. So I think I'm going to call it there. So let me stop the recording.